Hello, this is a demo of the tool created for the thesis automatic generation of graphical editors from graphical notation specifications. The first step that we will be showing is how to annotate the meta model for the generation of this tool, where we will start with some initial annotations. These will show the basic properties of the series editor, which we'll go through, and yeah, basically this annotation will specify that its name is your state machine. The main class which the whole editor will be based off is also state machine, which is this class, and will act as the top element basically for the entire editor. And these are the name of the viewpoint and the name of the diagram. This path is basically for a path to a Java file which can be used to extend the implementation of the series editor. So the first element that we will show is called containers. These containers can contain other elements such as other containers. And the first container that we will create is called the composite state. This name will basically assign a name to which the elements are named in the editor itself, and it's not really connected to the meta model. The expression basically tells which feature or attributes will be used to contain the container basically. So basically the top here is what the composite state will be made from. The background and the foreground is basically just the style of the container itself. So the container itself will just be white. And considering we have not assigned any borders, it will also be black. And as this is the top container, we just assign the default, which is the element below the diagram basically. So yeah, the default element is basically containing all of the other elements of the diagram. As for the domain, it's basically is what the main class is for the entire diagram, and the domain specifies which class is used for this editor element. So this is composite class, and here we can also see that we have chosen to not have any icons for this container, which is basically just a generated one, so it does not really say anything anyway. The next part that we will show is called the nodes. In this case, it's bordered nodes, where the only difference between a normal node and a bordered node is that the border node will always be constrained to the borders of its container. And here we can see that the border node is called the entry point. Its expression, which is basically the same as this one here, is just entry points. Its style, which is a new annotation, specifies that this is how it will graphically be shown. So this style will basically just show that the entry point is a circular form. The height and width, well, it's the height and width. The label shows basically what the node will have as a label. This is what will be shown graphically in the node itself. And yeah, icon and color is the same. And here the container is basically that the composite state, which is this element, will be able to have a border node called the entry point, as well as a simple state, which we have not yet created. However, this separation basically states that the simple state will be contained in the composite state. And yeah, the rest of the annotations is basically a styling. And here for exit point, we can basically just copy paste and change some of the naming, and yeah, it's basically the same. Now as an example, we can use this as an example for the edges. The edges are basically what shows the connections between different elements. So for example, an edge between an entry point and an exit point will be shown as an arrow, or, well, whatever style the user has chosen. Here we can see some other nodes that will be in the composite state later on. And the type annotation will basically say that this is an element type edge. This means that the edge contains both the target vertex and the source vertex, versus a relation edge, which will only consider the target vertex. And yeah, basically, yeah, the annotation will also have the target finder expression and the source finder expression. This will basically tell that go into your own class and select the source vertex as its target, and the source will be the target vertex, which, yeah, should be the opposite. Oh, it's an outgoing transition, so it's the opposite. And yeah, basically, this style will basically just show that the edge should be shown as a closed arrow, or a filled closed arrow. And the container reduce will basically state that composite state will later have a state which is called contained composite state, and it is recursive. So basically the contained composite state will have all of the nodes that the composite state also has. And we can look at the annotation for this here. As we can see, it's another container called the contained composite state, and it will have the same mappings as the composite state. So basically everything within this will also be contained in this. And yeah. Next part is the tools. As the top will only have one state, it will not really be able to create new top states. Hence we will have only a tool for create the composite state, which basically says that the name of this tool is create a composite state. It will be of a type called the container creation description, which specifies that this will create a container, and the mappings basically show that this tool belongs to the contained composite state. And the reference shows which this tool will add states to. So yeah, it will add states to substates. Yeah, the node creation tool is also very similar. So it's basically the same, only that the mappings has two different nodes now. So it will be able to create entry points to the composite state and the entry points to the simple state. The edge creation tool is slightly different also. Most of it is the same, except that it will also specify which attribute, feature, or yeah, whatever you can call this, basically what it references as the source. And here you can see that it will use this is supposed to be like this, and this is supposed to be like this. And yeah, the container expression basically says where it should add the transitions to. So basically this will tell that it will add to the composite state instead of directly into the vertex. Like that. Yeah, but that was all, and now we can look at a completely annotated meta model, which looks like this, and we have mostly added the simple state and all the nodes for the composite state.